We did similar figures at the very, very beginning of the semester, if you guys remember when we did similar triangles. When we did the triangle stuff, and we had triangle ABC was similar to triangle XYZ. What's that? I'm reminding you of what it meant. When we had similar stuff, we knew that all of the angles matched up. So angle A would have matched with angle X, B, and Y, and all the same like that. But also if the sides had a common ratio. Santa, stop watching your movie. Thank you. They also had they had common ratios. They had common ratios of the sides. The sides had a ratio of A to B. So you were able to figure out different dimensions and things like that. This is all stuff we had done in the past. Now, what happens with it now is that we're going to talk about it in terms of their areas, their perimeters, and the side lengths. So if the scale factor, let me change this. If the scale factor was what we were working with, was A to B, the perimeters have a ratio of A to B. Their areas will have a ratio of A squared to B squared. Okay. This is, excuse me. When we do these things, like I said, the values, the numbers, and all that we're going to work with are going to be really easy. We all know how to make a fraction bar in the calculator, so we're going to be able to simplify fractions, we're going to be able to square stuff. It's going to be really straightforward. Okay. One of the things that we're going to get to also, if you see that the areas are A squared to B squared, take a wild and crazy guess what volumes are going to be. Very good. So when we get to this a little on Monday, then the volumes will be A cubed to B cubed. And what will happen here is that we're going to have two areas, and we're going to figure out the scale factor. So we're going to work left and right of either taking square roots or squaring things, or taking cube roots or cubing things, going back and forth between all these ratios. It's really not that difficult. It's just a matter of understanding how this looks. So we write these out here also, so we have. So scale factor. If your scale factor is in the ratio of A to B, that means your perimeters are in the ratio of A to B, which means your areas are in the ratio of A squared to B squared. And like I said, we'll get to volumes later. Okay. For example, if your scale factor is 2/3, if your scale factor is 2/3, what's the ratio of the perimeters? 2/3. Now, what would the ratio of the areas be? 4/9. Very good. Okay. All you have to do is square it. Very, very, very easy. Okay. Let's say your perimeter had a ratio of 3/5. What's the scale factor? 5/5. What's the area? Very good. 9/25. Hey, Ray. Drop something. Do you guys know how to square in a calculator? Just use the fraction bar and hit square and it'll work. Okay. Same thing goes with if you happen to have the areas. If you have the areas ratio, all you have to do to that is take the square root. You know how to take the square root of a fraction in the calculator? Remember? Why does it jump off the screen? Excuse me, guys. shut it off and start it again. Software is really weird when it's on this dock, or computer's been weird with dock the past couple days. Again, all I would do is hit second square root of a fraction, 81 over 144, and it'll give you your answer. Now, in your heads, you probably said, oh, 81 over 144, that was 9 over 12, but the fraction can be simplified further, and anytime you're doing scale factors and ratios like that, you always go simplified fraction form. Okay? Not too crazy? Let me show you what it's going to look like in terms of problems. So in this case, the area of this small regular pentagon is 27.5. Approximate the area of the large one. Well, you're given side lengths. You know that the side lengths here, from small to large, is 4 to 10. You okay with that? If that's your scale, if that's the ratio of the sides, what do you do then to figure out the scale factor? Go ahead. Just scale factor. It's the same. It's the same, but when you put that in the calculator, it'll simplify it, won't it? So if I put 4/10 in the calculator, what are you going to get? 2/5. Good. So that means your scale factor is 2/5. Now, from small to large, because remember I'm going small to large in this case, if I want to figure out the area, I square it. So what's 2 squared? 5 squared? 5. So I get 4/25. Those are my areas. Small to large. Now the problem, I think it said what? The large area was about 27.5 for the small one. On the bottom one. What do you do? Cross multiply. That's about as complex as this stuff gets. Okay. You're working back and forth with values. So if you cross multiply that, you get 27.5 times 25. Oops. I get that, and then I just have to divide that by 4. So I get an area of 171.88, approximately. Not too bad. Just moving forward and backwards on these. Okay. I'll have everything posted. I hope you feel better. You alright?
No, it was like, see, you do the same thing this day, and it's like, you had a walking over the door, you got a garbage can.
Bad memories, though, right? All right. The scale factor of 2 parallelograms is 3/4. So your scale factor is 3/4. Small, large, obviously. The area of a large parallelogram is 96 something squared. Well, if my scale factor is 3/4, what do I do to that to get the area? Square it. So 3/4 squared is 9/16. Again, small to large. So where do I put the 96 when I go to cross multiply? Top or bottom? Remember, it's small to large. Gee, I wonder what you have to do. Cross multiply. Math, yeah, that's also true. Do this cross multiply again. So you get 9 times 96. Hit enter. Divide that by 16. And the area is 54. 54 something squared. I forgot what it was.
So it's
Really not much to this. But I honestly, I think the catch, if you will, is when we get to some of the volumes, because then you just have to remember, are you squaring or are you cubing, things like that. That's really all it gets to. All right? Excuse me. Two triangles in. These two triangles are similar. And the question is, what is the scale factor? What did they give you to start with here? Areas. So if they give you the areas, going from small to large is the easiest way to think about it. What goes in the numerator? The small one. And I'm going this way, which means what do I have to do to that? The square root. So again, in the calculator, you just got to put square root. There it is. Square root, fraction bar, 50 over 98. What's the scale factor? 5/7. The goof part, like you were saying, when we throw in volumes, you have to know how to take a cube root. And we'll, like I said, we'll just do that. Do I need to do another one? It's kind of what I'm thinking. It's not, like I said, it's not a real difficult thing to work with. I think by putting this today and doing a little bit of it on Monday when there's people that are with movies and stuff, that way we can add the volume thing to it and it'll be very, very easy. So let's do these. Did you guys know that you still have a textbook? I don't know if you knew that.
No.
I know we haven't used it in so long, right? So this is on page 638. Oh, quit your whining. I got a textbook here, you can take a picture of it too. So there. All right. If you would like to take a picture, if you'd like to use the book here, by all means, there it is. But this, break the camera. But yeah, honestly, this shouldn't take you very long. I think this is a pretty decent thing for Friday. Go easy on it here. Monday we'll throw in the volume part to it. That again shouldn't take very long to get through. But I know with so many people missing out later in the day on Monday, it'd be easy to add that and just have them post it in the video. Okay. The book, if you click on geometry on the website and then just go off of that.